So look at what we have here. We have the Darwin129, which essentially is the DarwinFPV version of the 7-inch. It's low cost, but not low performance. It has all the bells and whistles, but this is PNP, so we're going to put the latest and greatest from TBS Crossfire, the TBS Crossfire Nano RX Pro. So previously, you would always put on the Nano RX, which works with your TX transmitters, but this one is the Pro. What's the difference with the Pro? Let's get right to it. So before we open up the Darwin129, what we will do is let's look at the Nano RX Pro. Open it up. It says here, attention, requires 6.14 or later, Nano RX cable set. Let's take it out. Okay. Because it's RX Pro, just like the SE or Special Edition, if you have Nano RX SE, it comes in with the Immortal T. This is for the 915 MHz version. 868 would be slightly different, would be slightly bigger, I think. So you have the RX Pro. So it actually looks very, very similar. It has the UFL, it has the bind button, it has the same configuration, which really is ground, 5 volt, TR, channel 1 and channel 2. So it transmits out from channel 1, receives from channel 2. But, okay, because I'm not going through the electronics because I really don't know what's the difference. But it actually has boosted up the power of telemetry. So right now with your TX, you can go up to 1 watt with your micro TX V2, or you can go up to 2 watts if you have the full-size Crossfire module. But you're limited by your telemetry, which essentially is the way that the RX talks back to your radio, gives all the information that it reads from the flight controller, but it's always limited to 25 milliwatts. So essentially, it actually has a 500 milliwatt transmission of telemetry, so you can get all the important information like voltage, like GPS coordinates, current, anything else that you might find useful that typically is used for long-range pilots. So let the unboxing begin. So you have your Gem Fan 7043. Okay, so that's great. So you have all the TPU already pre-made up. Great. Okay. Your GPS is on top. So I think this must be bottom mounted. So we mounted the battery on the bottom, right? Okay. GPS is on top, all right? Which won't interfere with the antenna video transmission. So you have the strap, you have the long antenna, okay, and you have everything you would expect: wires, extra nuts, and they even have extra cable ties. Okay, well, let's put that aside and let's look at the craft itself. Alright, the craft looks really, really nice with the GPS on top. It has a GoPro mount and it is bottom mounted with LiPo. It has the battery pad to hold it in place. There's nice long silicone battery leads. Okay, so you basically just power it up that way. It has LEDs at the bottom, so you can see when your craft you know the direction of your craft. So this helps with line of sight. It is 280 millimeters wheelbase. Okay, so you can fit your 7040 on top. Let's just put on the antenna. Okay. Alright, that's nice and long right there. I actually like the way this is designed, just like a racing drone where it's bottom mounted, with the batteries bottom mounted, which then does not interfere with the antenna. Okay, which is great. It doesn't interfere with the GPS, which is great, because sometimes what happens is because you have the battery also on top, you have to try to figure out where to put the battery. It either stop on the GoPro or you have to stick it way behind, interferes with the antenna. Now the solution with having it underneath solves that issue. I think a lot of thought has been put in by the engineers at DarwinFPV, okay? The evolution, so to speak. So the VTX itself is 800 milliwatts. They have their own version of the TX805. I don't think it's a clone, or I don't think it's a copy. I don't think it's an e-sheen. I think maybe who knows? I'm not going to speculate whether it's a clone or a copy. They have 2507 motors. Seems to me 2507 1800 kV, so it can actually go 3 to 5S. So it's not 6S. Sometimes you think that 800 kV with 6S is not. It's 1500. It's 5S maximum. Okay, which is good. You can put a very hefty battery on here, and I would think to give you the longest range, you would actually opt for a naked or run cam thumb maybe. Okay, so the motors are 2507, okay, 800 kV, right? DarwinFPV motors. I would put some tape on to cover the race wires. I would not put any LEDs on here. There's no point, because the thoughtfulness of putting it at the bottom makes much more sense. There's no point putting it on top or even on the sides. Some people put it all around, and then you can't figure out which direction is which. This way, worst case scenario, if you had to fly LOS, it will still work. It has the picture of the baby ape. Alright, that's great. Okay, alright, so what we'll do here, we'll open it up and then put on the Crossfire Nano RX Pro. Okay, let's open it up. Okay, open it up. Let's go. Okay, it has an arm thickness of 5 millimeters. Okay, 5 millimeters, which is good. I think, while you're not planning to take this and beat the crap out of it, you would still want it to survive a crash, and 5 millimeters is, I think, is sufficient. You don't need 6 millimeters, which would be too heavy. You still want to save weight. Okay, let's take this apart first. While I'm doing this, let's look up what the GPS is. GPS, I think it's just a version of another BN200. No, it's not. The GPS is an M80, which actually should give you higher rates of searching, but at the same time, a lot of people complain about, I can't get the GPS lock. You really have to have been in an open area without interference. This is not a DJI craft where you pay thousands and thousands of dollars. This is still a DIY craft where, okay, it's off. It's off now. Okay, so it has its own DarwinFPV TX805 5.8 gigahertz 40 channel 800 milliwatts VTX. Okay, so let's pull out the GPS connector. Okay, all right, let's take that out. Let's pull out the connector for the VTX. And then while I'm doing this, also looking at the camera is also a DarwinFPV camera, but it's been upgraded, I believe, 1500 TVL. Alright, so 1500 TVL, which is TV lines, essentially is the indicator of the quality of the analog camera. So 1500 TVL, that's great. It's called the Darwin B19. Okay, taking that aside, so now let's look at the flight controller. Alright, I'm going to put on the diagram on top so you can see. Alright, so this is basically where you had the VTX come out and connect to the VTX connector for the flight controller. That's the direction right there. This is ESC connector. This is camera. Okay, this is camera, ESC. So this is GPS, and that is LED. Okay, all right. So now let's just look for free UARTs in order for us to put our Nano Pro on and then solder it on. Okay. All right. This flight controller is an F4, and you have a 50 amp ESC at the bottom. So just to show you, I'll take that out. So 50 amp beefy ESC at the bottom. Right, so you have the 50 amp ESC at the bottom. Okay, this amazingly, this flight controller, even though it's F4, okay, it actually has Bluetooth. So you have the USB here, but no, you can connect through Bluetooth. I can use the SpeedDB app and just set it all up. That's great. And for the cost of the Darwin129, is not too shabby at all. Okay, so what's amazing about this so this is the newest version of the F4 flight controller. 50M ASC, D-Shot 600, that's what you're going to use. And the F4, it has an SD card slot, okay, so for all your black box goodness. And it also has Bluetooth. So what we want to do now is connect the RC link. So out of all the connectors, this is where we're going to put it. But because this is mainly configured for FreeSky, if you look here, it actually says RC 5V ground, RC 5V ground. Basically, this connector goes into a FreeSky connector. Or if you want PPM, DSM, or iBus, you would then jump it according to which one you want. Okay. But because we are using Crossfire, we actually want a spare UART. And they have spare UARTs here. That's great. Okay, so we're gonna use TX2 in this case, just like as advised by the manual. So TX2 RX2, and then we use the 5V and ground from here, and then we'll place it away from the gyro. Okay, the MPU 6000, which is great. This is very rare. Right now, this costs 10 times more than it had cost about 2 years ago. So MPU 6000 is great because then it gives you 8K PID loop. You can still use 4.2 software. I actually want you to stay away from 4.3, just go with 4.2. Alright, so let's solder it on and come back later on the configuration. Alright, so I have my Nano RX Pro already soldered on, and I have my antenna mounted onto the UFL, but now it actually goes across the receiver versus going out. And the reason why I actually want it is because with the shrink wrap, it not only protects electronics, not only it strengthens UFL, but now when I shrink wrap it, it also hauls onto the antenna to the receiver, so it makes it a little bit more stronger. Okay, so where am I going to mount this? On the Darwin129. Looking here, there's not much space at the back. There's a LED at the bottom. They didn't give me TPU for the mount of antenna, which is fine. I'm going to mount it on the arm anyway, underneath. So here behind the camera, there's some space there. Right, so you can either double tape it in, sticky tape that in, or hold that with the cable ties it gave. Okay, so we can mount it somewhere there, and then mount it at the bottom like that, and which is fine because again the design of the LiPo at the bottom will always protect the antenna from any impact. Okay, so we'll mount it that way, and then we'll use some spacer in order for the antenna not to touch the carbon. Okay, and you'll have great signal. Okay, so now let's mount it and then solder it onto the flight controller. Okay, so if you look here, I managed to now route the wires properly. I've mounted the antenna this way, and the reason is I actually wanted to configure the bind button to be at the bottom, pointing backwards bottom. You can see that. So the bind button is tucked neatly underneath and it's accessible, no problem. I'll show you in a bit to show you what I mean. So right now the wiring is 5V ground 5V, and then RXTX. I'll show you in the diagram right there. So it's now right tucked nicely, neatly near the underneath the ESC and the camera, and it's all protected. So we should be able to mount that, no problem. I know I'm taking a risk of assuming everything is okay, but for the purpose of this video, I'll put it all back together for you. Alright, very important step. Open beta flight. I have 10.8, which I can use for 4.2 or 4.3. Let's check out the accelerometer. Everything works. Okay, good. And now let's go to the ports tab. Remember, we put it on RX3, so enable RX3 for serial RX. Save. And then let's go to the receiver tab after it loads up again. Receiver tab. And now we need to choose the right protocol. So the right protocol is Crossfire. Okay, choose Crossfire. Alright, so now beta flight, basically the flight controller is ready. So let's go now to TBS Agent M mobile. I know I said desktop, but for some reason right now TBS is pointing us to the mobile version. So we now update to 6.19. Remember, the TBS Nano RX actually asked for 6.14 minimum, but 6.19 TBS just put it out, and it says that it removes all the bugs for Nano RX Pro. So let's just use that. The only difference is for using TBS Agent M versus X is you go to this website, blacksheep.com/agentm, and then when you connect the USB, it will ask you to link to your Tango 2 or all the other controllers with the external module. Do that, and then it just automatically goes through the motions from preparation, going through the subsystems, and then finalizing the flash. Alright, so when you turn on your quad, you'll actually see that the Nano RX will be flashing green, which means it's in bind mode. So now you need to put your, in this case my Tango 2, in bind mode too. So I go through the Crossfire settings, I go to bind, and then when both of them see each other, both of them are going to link automatically. So thank you very much for staying right to the end. Like and subscribe.